Hello, Algebra 2. Here we are with day 2 of completing the square. Okay, we're going to start you off with one that we finished with yesterday. Remember, the b term is the key. So that negative 12 is going to get us started. We're trying to make this be a perfect square trinomial so we can go to parentheses squared and then use square roots to solve. So that b term is going to control what we need over here. So step 1, we're going to cut that b in half to negative 6. Then we square it to be positive 36. Now I want that spot, the C spot, to be 36 so that this will then be a perfect squared trinomial. Two ways to go about it. We talked about two ways yesterday. So this is like our unwanted house guest. Okay? We can just kick it out, subtract 24 from both sides, and then bring in 36, add 36 to both sides. That's two steps. Not a lot of thinking, but it's just easy to do, okay? That's not the number I want. Boom, get rid of it. Now add the number that I want, and now I'm done. Okay, one step takes a little bit more brain power, though. You got to think, how can I make 24 be 36 if I add 12? So now we have x squared minus 12x plus 36 equals 12. Okay, think about it if you would have gone the other way. You would have minus 24, and then you would have added 36, and it would be 12 over there. Alright, now the whole point of doing this was so that it would be a perfect squared trinomial, and it's going to come down to x minus 6 squared. Okay, half of this. And we want that to happen so that we can use square roots to solve. And now we have x minus 6 equals the square plus minus square root of 12. Okay? Again, I don't care what order these next two steps happen in. They just need to happen. I have one that I prefer. Okay, we need to get the 6 over there to get x by itself, and we also need to reduce the radical. I like to move the 6 first, because I think if you reduce the radical to 2 radical 3, that you're going to be tempted to put the 6 and the 2 together. So I'm going to add 6 over, and now break these apart. 12 can be radical 4, radical 3. We'll have 6 plus or minus 2 radical 3. Alright, x equals. That's where we ended yesterday. Okay? Not too bad. Hopefully you're feeling pretty comfortable with that. Today we're going to add a number in the front, and that's going to make things a little bit more challenging. Okay? It's going to make it more challenging because it does add a step. Or 2 steps, I guess. It adds 2 steps, one in the beginning, one at the end. And it's going to make us work with a lot of fractions. A lot of fractions, okay? So, step 1 is we're not even going to wait and see. We're just going to get rid of that 5. Minus 5. Okay? Step 2 is we don't like that 2 on the x squared. We want it to just be x squared. So you're going to factor 2 out. Now it makes it a nice x squared there, but if I take 2 out of this, because you have to do it to both, now it's minus 7 halves x. And that's what's going to cause us a little bit of difficulty. I know you guys don't like fractions all that much. Now it's the exact same process still. We're still going to look at the b. We're going to cut the b in half and square it. So our b is negative 7 halves. What's half of a half? A fourth. Negative 7 fourths. And negative 7 fourths squared is 49 sixteenths. So we're going to add 49 sixteenths in there. I'm trying to think how I want to do that for you. plus 49/16. And before you add it to the other side, where did I put that 49/16? Right in the middle of a parentheses that has a times 2 attached. So all these things get times 2. So this 49/16 is actually 98/16 is one way to double it. Double the top. Another way to double it is to cut the bottom in half. 49/8. 49/16 times 2 math frac 49/8. So I'm going to go with the 49/8. So that is a big thing, a difficult thing for a lot of kids to get through. How this is a plus 49/16 and that's a plus 49/8. Recognizing that this is in a group that's times 2, so even though I put 49/16 there, I didn't really add 49/16 to the left-hand side, because that's 49/16 times 2, which is really 49/8. So that's probably one of the hardest steps, all this fraction manipulation. Alright, next, the same thing that we always do. That was the whole goal, was putting this here so that it would make it be a perfect squared trinomial. X minus half of this, 7/4 squared. Okay, for this part, that's not too terribly difficult to do mentally. You'd need a common denominator of 8. So it'd be negative 40 over 8. And negative 40 plus 49 should be positive 9/8. If you don't like that, we can go negative 5 plus 49 divided by 8. Alright, decimal, Mr. Handke, that's no fun. Math. Okay, third button down. I guess technically the fourth button down on the left. Math. Frac. We'll turn your last answer into a fraction. 9/8. Some people are really dependent on that fraction bar. You guys don't like doing the 49 divided by 8. You have to have that fraction bar. Negative 5 plus, if you absolutely have to have that fraction bar, it adds more buttons to push. It's faster just to do 49 divided by 8. But if you absolutely have to have it, alpha y equals first one. There it is. You still have to go back and do the math frac to get that fraction. Okay? But we got 9/8 over there on the other side. Alright, now we're going to go through and divide by 2. 9/8 divide by 2. Same thing we did here. When we had 7/2 divide by 2, you just double the bottom number. 9/8, cut it in half again, would be 9/16. And that's actually, I know you guys are upset about these fractions, that's actually a pretty nice fraction to have for this problem. Because the next step is to square root to cancel out that square. I don't need parentheses anymore. And when you do the square root of a fraction, you're really doing the square root of the top and the square root of the bottom. So we're going to have plus minus 3/4, which is going to match up really nice with our 7/4. Okay, we're going to add that 7/4. Okay, and however you want to do this, again, I like to kind of just do an up and a down. Plus, minus. If you want to rewrite it and do it over, however you want to organize that, that's fine. 7 plus 3 is 10/4, which is 5/2. And 7 minus 3 would be 4/4, which is 1. So we got some decent answers at the end. Okay, just that kids don't like to deal with the fractions. So, what was different? Factoring out this 2 was an extra step. Okay, it was. Then it's still the same stuff. Half of your b number squared. Okay, we add that here. It's inside parentheses that are times 2, so make sure we adjust what that value actually is before adding it over there. Then we condense it down to parentheses squared. Here's the other extra step when you have to divide that 2 over. Okay, and now we square root, and we solve. It's just that it has fractions all over the place that make it a little bit scary. Alright? Here's another one. It's the exact same problem, so we're going to change this. I don't know what I was thinking when I wrote that down. We're going to change this to a plus and this to a minus. Okay? 2x squared plus 7x minus 5. So it should be very, very similar. Just that it's going to have some things switched around. Otherwise, a lot of the numbers are exactly the same. Okay, this one will have a square root on top in the end. So don't panic when it doesn't come out perfect on top. Go ahead and push pause and give that one a shot. Okay, let's take a look. So step 1, automatically just get rid of that number. Boom, add that 5 over there. Okay, then we're cutting this, we're taking this 2 out. So it's 2 times x squared plus 7 halves x. Okay, 7 halves is your b. So we're going to cut that in half. 7 halves cut in half is 7 fourths. 7 fourths squared is 49 sixteenths. So I added 49 sixteenths here. But remember, it's not 49 sixteenths, it's 49 sixteenths times 2, which is 49 eighths. Now this time this 5 is positive, so when I add 49 eighths plus 5, which would be 40 eighths, we have 89 eighths. Okay, divide by that 2, now we have 89 over 16. Square root. And we have, can't do the square root of 89, so that stays there on top, but the square root of 16 is 4 on the bottom. And now I'm going to minus the 7 fourths. And technically they're both over 4, so we can squeeze them together. Is one fraction. Negative 7 plus minus radical 89 on the top, all over 4. Alright, that was a tough one. These are all tough when there's a number in the front, just because there's a lot of fractions. Okay, and I don't remember if we got into any imaginaries yesterday, so we're going to do some imaginaries today. After doing those 2 problems, this isn't going to be very bad. You're going to love this because it's only 1x squared, so super easy. Okay, again, the b is the key. What's half of negative 4? Negative 2. Negative 2 squared is positive 4. So again, we have a choice. Do you just want to subtract 12 and then add 4? Or do you want to think about what you have to do to 12 to make it be 4? Okay, I'm going to minus 8. Because 12 minus 8 is 4. That's the goal, to get that to be a 4. The goal to get this to be a 4, so we can do parentheses squared. We're going to have x minus 2 squared. Half of this number equals negative 8. Now that we have the whole left side is something squared, we can square root. Square root of a square is just going to be x minus 2. Square root of negative 8. I'm going to add the 2 over. Oh, we got to do plus minus on my radical. And last now, I'm going to reduce that radical 8. We're going to go negative 4, positive 2. I can do the square root of negative 4 now. I've told you the truth about square roots of negatives. Plus minus 2i, imaginary 2. Radical 2. Whole lot of 2's there. Whole lot of 2's. Okay? Told you. Seems pretty easy now after doing those other ones with the 2 in the front. Or wait till you see your homework and there's a 3 in the front. Okay? We figured out what number this needs to be for it to be a perfect squared trinomial. Cut that number in half and square it. We need positive 4 there. You could have just as easily subtracted 12 from both sides and then added 4. Would have resulted in the same thing. Okay, from here, we got that plus 4 there in the C spot, so now we can go do parentheses squared. We want those parentheses squared so that we can solve with a square root. Okay, we're going to get that other 2 over there to get x by itself and reduce your radical. You can do those 2 steps in either order. You could reduce your radical first and then bring the 2 over if you wanted. Alright, and there it is. Okay, let's have you try one of those on your own. That one actually works out pretty clean. Go ahead and push pause and give that one a go. Welcome back. Okay, so x squared minus 12x plus 40. This time I did the kick-out method. Alright, because we did the other way over here. So half of negative 12 is negative 6. Negative 6 squared is 36. That number's not 36, so I got rid of it. Minus 40. Then I added 36 to both sides. Now it's only negative 4 over here. That made this side be a perfect square trinomial. X minus 6 squared it comes down to. Now I can square root. Okay, we got x minus 6, and this actually came out nice. Plus minus 2i. Now I add the 6 over. Don't put those together. They're not the same. One's a real number, one's imaginary. 6 plus minus 2i. The end. Alright, folks. Thanks for watching. Thanks for bearing through that. Those fractions, man, those are tough. But if you keep practicing and practicing, you'll get more accustomed to them, and they'll be less scary, and you'll do better with them as you go. Alright? Thanks for watching, and good luck.